Okay, so we're moving on in complexity, but it's still pretty much the entire same process, okay? So this time it says instead of 1 meter high, the statue is h meters high. The base of the statue is still 1 meter above the line of sight. Modify the model in question 8. So, in question 3. Let's just draw it again. What that means is that this distance is still x, A, D, B, C. This distance is still 1, but the height of the statue above is h. Okay? So we need to adapt things as we go. That we'll still let this be angle theta and this be angle alpha for consistency. Well, what we know is that basically this distance AC will still be x plus 1 squared, square root, whereas AB is going to be, well, that's going to be x squared. So AB squared is going to be x squared plus h plus 1 squared. So AB is equal to x squared plus h plus 1 squared square root. Okay, so let's just write that in. Square root of x squared plus h plus 1 squared. Okay, so what changes exactly? Well, that means ABC will change, theta will change. That will become sine theta is equal to x over the square root of x squared plus h plus 1 squared. Okay, sine alpha will become sine alpha over 1. Yeah, still, sorry, sine alpha over h, because this distance is now h, not 1, is going to be equal to sine theta over the square root of, sorry, this one is, yeah, that's right. Yeah, that's right. So that's going to be x squared plus 1. See, I often doubt myself and make mistakes when I'm doing this. No problem. You can go back and fix them as you go along. So we're saying sine alpha is equal to h times sine theta, which is, so that's going to be hx over the square root of x squared plus h plus 1 squared divided by the square root of x squared plus 1. So my final answer, I'll write it up here, sine of alpha, sine of BAC, that's what alpha is equal to hx over the square root of x squared plus h plus 1 squared times x squared plus 1, all of that under the square root. Okay? The 1 meter high statue is replaced by a statue that is 2 meters high. Use your model from part A to find the change in the largest angle of view. So basically what all that's saying is A is 2, sorry, H is 2, becomes sine of BAC is equal to 2x over the square root of x squared plus 3 squared is 9, okay, times x squared plus 1. Okay, so all you need to do is put that function into your graphic calculator and see what the largest angle of view is. So I'm just doing that now. That's going to become 9. That's going to become, change that to 1, and that's going to become 2x Okay, and I've got a new maximum at x equals 1.732, y equals 0.5. So that means at the maximum, sine BAC is equal to a half, and that means that the largest angle of view is going to be, well, if I, you should know that one, that's 30 degrees, okay? The corresponding distance from the column is the value of x that gives me that. That's 1.73 meters to 3 significant figures, okay? So this is the x value of your maximum. This is the y value of your maximum, which you then use to get the 30 degrees. Okay? So again, hope that makes sense. If any of this stuff doesn't make sense, you need extra help, just ask. Okay? And there we go. We're done. So hopefully you can see, actually, paper 6 part B, the modelling, is quite easy if you just understand the first part of the question. Because the next parts of the question will ask you exactly the same thing, but will just ask you to introduce more variables as you go, generalize your model a bit further, okay? So that is the secret. Question 1 will be easy. All you've got to do in the following parts is use the same process that they've given you to begin with, okay? If you see the simplicity on that,